huge black holes at the beginning of time could be messengers from a previous universe. Evidence from the latest images from the James Webb Telescope leaves no doubt that these black holes must have existed before the Big Bang. But where does this discovery lead us? Straight into a new cosmology of cycles, into an eternal universe, or back to the beginning and the Big Bang? Experts are arguing about the latest images, and we'll show you why none of the scientists can be right. Sears 1019 is a shock to science. A supermassive black hole has been found at the center of a very early galaxy. The galaxy, also known as EGSY 8P7, was discovered as part of the JWST program Cosmic Evolution Early Release Science Survey, or SEWERS for short. The black hole defies all expectations of what could have happened at the center of early galaxies. With a mass of approximately 10 million solar masses, and at a time approximately 13.2 billion years ago, this black hole is scientifically impossible. A black hole of this size could never have existed just 570 million years after the Big Bang, if our science is even remotely correct. But is it? Can science really be right? Or will science always be just an attempt to approximate the truth that we may never fully understand? The research team that discovered the black monster at the center of the galaxy used all 4 brand new instruments of the James Webb Telescope for their observations. In just 1 hour of exposure time, the super telescope analyzed all the facts about the galaxy and its mysterious core. In addition to the supermassive black hole, the galaxy shows signs of active star formation and an active galactic core. These are further facts that argue against a young galaxy. 10 million solar masses in just 570 million years? Can a black hole really grow to a mass of 10 million suns in that time? The discovery of the massive black hole at the center of the galaxy Sears 1019 poses a puzzle for modern cosmology. According to classical theory, a black hole would need considerably more time to reach such a gigantic mass. According to old ideas, black holes were formed by the collapse of stars and subsequent accretion, which is the collection of mass by swallowing material objects. But how could there have been so many objects in the early universe? Supposedly, the Dark Age, in which there was no matter at all, had only just ended shortly before. One conceivable scenario would be the existence of a so-called seed black hole. This would not have been created by a star, but by the direct collapse of a huge primordial gas cloud. These objects could have started out much larger than ordinary stellar black holes, and thus had a head start in growth. If the accretion rate, the rate at which a black hole eats mass, was also higher, this could be an explanation. However, if matter fell into the hole extremely quickly in phases and was dissolved at breakneck speed, this would mean that the Eddington limit was exceeded, or that it is not an absolute value. The Eddington limit is a kind of cosmic speed break for the growth of black holes. It was named after the British astrophysicist Sir Arthur Eddington. He discovered that when a black hole attracts material, the material becomes hot and begins to glow. This creates the bright accretion disk through which the otherwise invisible black holes become visible. The resulting radiation generates outward radiation pressure. At the same time, gravitational force acts inward, attracting more material. The Eddington limit is the point at which these two forces balance each other. In extension, the idea is that too much matter generates more radiation. The radiation pressure blows away material and growth stops. To explain the rapid development of black holes, such as the one at the center of the galaxy Sears 1019, the Eddington limit would have to be suspended, at least temporarily. But then astrophysics would have another problem, because the scales used to formulate the limit would be wrong, or at least incomplete. Alternative models assume that black holes can grow faster than the limit allows in certain phases. Possible explanations include chaotic accretion, in which gas flows in more quickly than the radiation can blow it away. Shielding, in which dense gas clouds block the radiation so that the radiation pressure is not as strong. Or a super Eddington phase, in which short periods of extremely rapid growth allow monsters like the one in the galaxy Sears 1019 to grow. You can imagine a super Eddington phase as a black hole that races and then slows down again. Black holes in the dark ages. Is that possible? The so-called dark age ended around 1 billion years after the Big Bang, when, at least in the imagination of our researchers, the first stars and quasars ionized the universe, and light was able to circulate freely. However, Sears 1019, along with the black hole at its center, already existed 570 million years after the Big Bang. This would mean that both the galaxy and the black hole are located in the dark ages. But how can this be? Is it possible that the universe did not ionize and light up everywhere at the same time? Stars and galaxies may have developed more quickly in some regions. But let's be honest, when we put all the facts together, science is bending over backwards to somehow hold on to its old theories. We must remember that Sears 1019 is a galaxy that was not born 570 million years after the Big Bang. Even though the galaxy is small according to our old standards, it needed at least several hundred million years to grow, just like the black hole at its center. This would bring the time of its birth closer and closer to the Big Bang. The probability of a dark age is decreasing dramatically, and our scientists are finding it increasingly difficult to explain. Now, quite a few researchers are saying that galaxies grew faster back then. All these turbo growth theories are currently more popular than claims that our old lambda CDM model might simply be wrong. This would also rule out theories about the Big Bang, the age of the universe, and the idea of expansion for the time being. Why black holes are located at the center of galaxies is also still somewhat of a mystery in the dark age of our science. By which I mean we simply don't know. But no one is willing to admit that openly at the moment. What is certain is that black holes are gravitational anchors. Their immense mass influences the dynamics of the surrounding stars and gases, attracting matter and driving structures. Black holes could thus have attracted the first stars and gathered them around themselves. However, they may also have been involved in the formation of galaxies themselves. Some researchers even suspect that certain types of black holes are something like eternal phenomena of the cosmos. They have always been there and will always be there. They could even be relics of what existed before the Big Bang. If so, they would be a fundamental structure of our universe, and possibly even a driving force of creation. Here, too, we must recognize that our research is still in its infancy. Sears 1019 is definitive proof that we are still a long way from completely unraveling the cosmic puzzle. More giant black holes discovered. Now you might think that the black hole at the center of Sears 1019 is an exception. But no, that's not the case. Another monster has appeared in the JWST data that breaks all boundaries. A black hole with 800 million solar masses has been proven to have existed only 670 million years after the Big Bang. This black hole is even more massive than Sears 1019, but it does not yet have a name, and the galaxy surrounding it has not yet been explored in detail. As if our researchers didn't have enough to chew on, they now have to come to terms with the fact that other researchers have announced the discovery of a black hole with 1.66 billion solar masses. This giant was spotted 690 million years after the Big Bang, and is such an extreme example of rapid growth that all ideas for adjusting the Eddington limit are now obsolete. Our researchers have no choice but to rethink their ideas and question old models. The current goal of research into the JWST data is to find evidence of even older black holes. The further back we look, the more likely it becomes that the ideas of the Big Bang, 13.8 billion years ago, and of the spatial and temporal beginning of the universe in general, will soon be off the table. What are black holes anyway? Well, there are scientific definitions, such as objects with extreme gravitational force from which not even light can escape, the remnants of stellar explosions, and places where all physical forces are infinite, so that they cannot be further defined. But that's not much we really know. And secondly, black giants harbor a great deal of as yet unknown potential. We currently know of 4 types and classes of black holes. Stellar black holes with approximately 3 to 100 solar masses. They are formed by the collapse of massive stars and are the most common type in our galaxy. Supermassive black holes have millions to billions of solar masses and are located in the center of almost all galaxies. Their origin is still unclear. They may have been formed by extremely rapid accretion or merger. Intermediate mass black holes have 100 to 100,000 solar masses. We list them third because they are rare and difficult to detect. They could be possible bridges between stellar and supermassive black holes. Primordial black holes come in fourth place because they are purely theoretical. According to model calculations, they were formed immediately after the Big Bang. They probably arose as a result of density fluctuations and could provide important clues about dark matter. These first black holes may also have been much more common and merged to form the first giants. In our current understanding, black holes are formed by the collapse of a massive star, the merger of several small black holes, or gas accretion. Violent primordial density fluctuations could have contributed to the formation of primordial black holes in the early universe, or the direct collapse of gas clouds without star formation created the first large black holes, which then merged to form ever larger objects. Such first black holes could also have contributed to the formation of galaxies by attracting loose stars, gathering them around themselves, and shaping them through their dynamics. The fact is that today, trillions of stars orbit galactic centers, which are almost always black holes. The fantastic shapes of spirals, disks, or spheres could be influenced by forces emanating from black holes, quasars, and interactions with their surroundings. Research into how many galaxies really formed is still in its infancy, precisely because nothing about the first galaxies had really been proven until now. Researchers were excited about the images of the first galaxies in the young universe. However, what the James Webb Space Telescope actually showed us did not meet the researchers' expectations. Subscribe to the channel now and stay tuned for more videos.